Hello, everyone. Can you hear me? Okay, cool. All right, so today's our last lesson. So maybe some of you have gone back to school now, today on Monday, right? But I think some other schools will start maybe tomorrow or Wednesday, I think. All right, so we're gonna have, so this is our last maths lesson, and tomorrow is our last chemistry lesson. And for physics, we might have extra the 9th lesson on Wednesday. That may or may not happen. So I'll let you guys know. All right, so we're going to spend some time today reviewing what we learned in the 7 lessons. So we're going to do some integration. And also, I forgot to teach you this one here, which is known as normal approximation to binomial. And this is really, really interesting topic because binomial distribution, as you guys know, is a discrete random variable. And normal approximation, well, what's normal distribution? Normal distribution is continuous random variable, isn't it? But normal distribution sometimes is quite difficult to calculate if you don't have a calculator, because you have to figure out probability that x is equal to like 2 and probability of x is equal to 3, and you might want to do that up to like probability that x is equal to like 90 or something like that, and you want to add them all up, then that's going to take too much time, right? So there are 2 ways of doing this, which is first way is you can do the normal approximation. You can treat this normal distribution as if it's normal distribution. That's a binomial distribution. You treat binomial as if it's normal. And second one is use binomial, CDF rather than PDF. So I don't think I properly explained this concept. So CDF, so the C here represents cumulative. So that means that includes all the, so for example, if I go for binom, and in my calculator, if I go for X and then N and P, what that means is I'm calculating probability that the X is less than this number here. So let's say if that's 5, then that's 5. So if I go for 5 here, and that's 10 trials and probability 0.5, that means this one is just including 5 as well. So this is a P of 0, P of 1, P of 2, etc., etc. So there is a calculator function that allows you to do all this in one go. And the PDF is related to just one particular value. So there is a way to do that. However, like many years ago, people didn't have a calculator, so they used a normal distribution to approximate the binomial. So we're going to come back to that later. First of all, and we're going to do also lots and lots of questions on expectation algebra and probability and things like that. Okay, so we'll spend some time today going through questions. All right. So here is one question, so you guys can see. So find the area of region P. So this region here. So we have 2 equations, which is this one here and this one here. So that's the red one, and that's the blue one. All right. And we have this region that's in between this blue curve and the red curve. So I think there are 2 ways of, let's figure out the Q first. I think Q is a lot easier. So area of Q. So this area here is sandwiched between this function and this function, right? So that's integral from 0, from right here, to right here. So 0 to 1. And then we do e to the x minus e to the negative x dx. So that's pretty simple, right? And that's equal to e to the x minus e to the, if we integrate this one, then we get e to the x. If we integrate this one, it's negative x over negative 1 because of the anti-chain rule. And you have to, of course, so this cancels and that becomes just a plus, right? And that's 0, 1, and therefore we can find this as e to the power of 1 plus e to the power of negative 1. And then minus, we plug in 0, 0 there, so we get e to the power of 0 plus e to the power of 0. So that's equal to e plus e negative 1 minus 2. So that bit there is 2, right? So this one can be written as e plus 1 over e minus 2 as well. So that's the answer for Q. Now, can you guys think about how you can calculate this area P? Can you guys suggest any method for this one? You can type your answer on the group chat. So I want you to think about it. What could be a good way to compute the area P? So the area P is all of this. Take a look, all of this. Okay, so Sarah is saying calculate the area above the red line and then subtract the area of Q. That's very clever. Yeah. So we can do, so I think this question should have been flipped. That's a really clever way. So we can calculate this area, so this area. Well, that's basically integral from that point. So I think that point there is negative 1 and e, is that right? So this is e, of course. So this is integration from negative 1 to 1. And then we can subtract the line. So this is a f of x minus like g of x and then dx. So f of x could be this line here. So that line is, this line over here is y equals e, right? So this one is e. And then minus g of x. G of x is this one, the red one here. So that's e to the power of negative x. Okay. So I want you to first type, let's log into Socrative, guys. It's been a while. Socrative. I want you guys to log in as well. Classroom name is John's Academy. All right, we've got, how many people have we got? We've got 7 people. Okay, so short answer. If you can't log in, you can just type your answer on the group chat. I want you to figure out what goes inside there, please. And this one is negative 1 and 1. Okay. Well, this is not right. What's integration of that? You will have 2 terms, right? So you can try this. I'm going to remove this one, so maybe you can try this again. I'm not sure if you are allowed to type answer twice. So I haven't got any answer yet, but you guys can try. Okay. This is very good. Just give me a second. So this is correct answer here. I want you guys to have a look at this. That's a good try. Okay. So this is a common misconception here. It's a good try, but unfortunately. Okay. So the answer is, that you see, when you have integration of 2 dx, the answer is 2x, right? So integration of e dx is ex plus c. So that's just a constant. So that's not going to be e to the power of x. It's just going to be e x. And then plus, and we already went through integration of this bit here, which is that bit there, right? So that's just plus e to the power of negative x. Right? So integration of e is e to the power of x, but then you got to divide by the differentiation of that bit there. So that's equal to, yeah, so that's what you get, and you plug in 1 and negative 1. So if we do that, that's e plus e negative 1 minus, plug in negative 1 there, you get negative e, and then plug in negative 1 there, you get plus e to the power 1. And this one is 2e, because this is a plus e there, right? And then this one is plus e plus 1 over e. So that's the area over here. Okay. And we can subtract the q from, this is q, right? So subtract that from here. Then we get, so you see, this is 2e plus 1 on e, minus this area, which is e plus 1 on e minus 2. Then you get the e, hold on, what are we doing here? This is 3e, right? This is 3e. So I should have just written like that. Yeah, that's right. So this is just the 3e, sorry. So this is a like term with this one. That's a like term with this one, but they cancel out because it's a minus. So this is going to be 2e plus 2. So that's going to be this area here. Let's think about another way of doing this as well. There is another way. So we have this graph, we have this, and we have this. That's y equals to e to the x. So this is y equals to e to the power of negative x. And we have this area here. And this one is e, right? And this one is negative 1, and this is 1. So we can flip this equation into x equals to ln y, right? And this one is x is equal to negative ln y. Is that right? Yeah, that's right. So we have two things. So to find this area, so if we think that this is up and this is to the right, and that is that one there. So this one minus this one would be the answer, right? From that point. So that point would be 1, because if you look at this one, that goes through 1. You know, e to the power of 0 is 1. So integral from 1 to e, 1 to e, and then you do ln y minus negative ln y. and dy. So if I do that, this is 1e, and then this is 2 ln y dy. But now integration of y, integration of ln is something that we didn't, we actually learned through integration by recognition. You guys remember? Integration by recognition. So I'm going to say differentiate x ln x, hence find, so here's a question, integral of ln y dy, d ln x dx, please, okay? So I'm not sure if you guys can do this. You can do this by product rule, you know? So I want you to try that right now and try integration of this one, please. Then we can do this one here, okay? So, yep, free response question. What you need to do now is just differentiate this guy. So what is differentiation of x ln x? So today's lesson is not going to be like me just teaching. We'll spend today's lesson, you guys actually trying a lot of these questions. All right, someone got ln x plus 1. Is that really right? Okay. So a lot of people seem to get 1 on x, but the answer is ln x plus 1, I think. So take a look. So it's a u dash v plus uv dash, right? So it's by simply using the product rule. So u dash is 1, v is ln x, plus u is x. Differentiation of ln x is 1 over x, right? So you get ln x plus 1. So that's the answer. So that means integration of ln x plus 1 dx is equal to x ln x plus c, true? If I integrate that, I should get this one, because differentiation of that is this one. So if I take the 1 outside, this is ln x dx, integral plus integral of 1 dx, and that's x ln x plus c. So integration of 1 is x. So this bit is just a x. So this is just x plus maybe c dash. So if I move these two to the other side, then I can find what ln x is. Integration of ln x is x ln x minus x plus c minus c dash. And of course, these two can be just written as capital C. Okay, I'm just wondering if today's lesson is being recorded. Yeah, it is. Okay, so that's what we know. So therefore, we can try something like this. So we can put the 2 out. Because we know the integration of ln x, now we can try this. This 2 comes out, 1e, and then ln y dy. So this is 2, and this will be y. This will be y. So that's my clue, all right? So this is a 1 to e. So I want you to try that again. Yeah, off you go. What goes inside there? Okay, I've got one answer, but I've hidden the answer. So I'll put it over here. So you need to fill in this point here, this bit here. We'll wait for 3 more answers, okay? So if I just move on after just receiving 1 answer, that's not fair. So okay, not getting any more answers. So let's have a look. So we've got yeah. So the correct answer is this one here: y ln y minus y plus c. But you should not have c, of course. Yeah, so if you just look at, so this is a very simple question, you know, if it's a integration of ln y, then it's a y ln y minus y, right? So this must be just a y ln y minus y. No c, of course, because it's definite integration. And we plug in e and 1, just to have a look. We usually change the square bracket into curly brackets like this. If there is a number in front of it, plug in e, so that's e ln e minus e, and this is a 1 here, so it's a 1 ln 1 minus 1. But you need to know that log of 1 is always 0, and the ln of e is a bit like log 10, log 10 is 1, isn't it? So in a similar way, log e is 1, which is the same as ln of e. That's 1. So this is equal to 2 curly bracket, that's e minus e, which is 0. And this is plus 1. So the area is 2. Okay. So what they're saying is that this area is 2. Maybe we made some mistake before. So according to this calculation, it's showing that the area here is 2. So let's see. I'm going to double check everything here. So we found the AP area here as 2. So this 2e didn't really cancel out, right? So let me just double check. That's 2 there. 1 over e. Zero to 1, ex minus e. Yep, that's right. That's plus, plug in 1, 1, 0, 0, minus 2, e plus 1 on e. You guys can let me know if you see any mistakes. So that's the area of, I believe this is definitely area of the Q. And if I figure out the area of this, which is e minus, that's from -1 to 1, e minus, that's right, ex plus e to the power of -x, 1, -1. That's right. Plus, all good, minus, plug in -1 there. negative e, and then plug in there, plus that down there, that's right, all good. That's 2e plus 1 on e. So if I subtract this from there, if I subtract that from there, that's gone. Plus 2, 3e minus, that's right, so it must be 2e plus 2. So I'm not sure why this is not canceling out. Let me know if you guys see some discrepancy. Well, I can double check with this calculator. So this is taking a lot of time at the moment. Okay. So the area, so integral of e minus e to the minus e to the x negative x from negative 1 to 1. Now that's giving us in decimals. I don't see where this one went wrong. So we figured out the answer for this area with two different ways. One method was figuring out this area of Q and then subtracting that from this area, and we got this one. And in the other method, we figured out we integrated from 1 to e and we subtracted this this from this, right? So that's ln y, so it's 2 ln y, which gives us y ln y minus y, exactly like this one here. And then plug in e, plug in 1, so plug in e, 1, 1, 1. That cancels out, that's 0. And that is just 1. So I feel like this is the correct answer. So there's something wrong with the first method, but I don't quite see it now. But I'm going to figure it out later and then post it on EDX, okay? Yeah, let's move on. Next. Okay, so this one here, the figure shows part of the curve sine x. So sine x looks like this. Continues sort of like that, you know? So that's sine curve, and we want to figure out this area. Okay. So what do we have to do to figure out this area? So it's an integral from, so we have to have something like this, you know? But remember, this is like positive area and this is negative area. So it is a bit, it's not really easy to do this area with just sine alone, because if you're using just the sine of x, you can only figure out the area between the curve and the x-axis. You see how this area here is not area between the sine curve and the x-axis. Well, this area here is area between the sine curve and the x-axis. So that's easy to find with just sine of x alone. So I want you to suggest what we should do to find the area here. All of this. You can do this all in one go. Okay? So I want you to try that. And just type your answer here, please. So this value here is 7 pi over 6 and negative 1 on 2. So, yep, off you go. The aim is to figure out this area. All of this area here. And you also have to find this value here and this value here. So I'll wait for 3 answers, and then we'll go through it together, okay? I'll just reveal answers, okay? For me, I think that's not right. So here's the thing. If I integrate the sine of x from 0 to 7 pi over 6, then what I'm doing is, so here is the function. You're integrating from here to 7 pi over 6, which is over here. So that's going to be, you're going to get this area. You're calculating this and this, but they are going to cancel. This will cancel out with like about this much. Okay. So you're integrating from here to here, but because you're going for negative here as well, these two will cancel out, and all you'll be left is the answer will be this bit here. So you get some value that is equivalent to just that value there. Okay. So if you integrate, have a look at this. If I integrate sine of x from here to here, this will actually be the same as integrating from 0 to, I think that's going to be 5 pi over 6 sine x dx. So if this over here is 5 pi over 6, and that gives us this area, which is equivalent to this area here. See? So if I integrate from 0 to 7 pi and 6, that's going to be the same as integration from 0 to 5 pi and 6. We're going to have a look at that here. But the question is, how do I get this yellow area? But everything must be positive. So of course, this is positive area, and this looks like it's below the x-axis, so it's negative area. But we have to take this as positive value. Okay, we don't want anything to cancel out. That's what we're trying to do. But I'm going to illustrate the point. I'm going to integrate from the sine of x here, right? Sine of x. Integrate that from 0 to 7 pi over 6. So that gives me, and this is in it must be in radians, so it gives me 1.866. If I go back and change this to 5 pi over 6, it also gives me 1.866, right? you understand the reason? So for this case, these two cancel out, which is essentially the same as this bit here, which is the same as this one. All right, I still haven't got any answer, so I'm just going to remove this one. I'm not sure if you can try that again. So how do we do this one? You can say, I've got no idea. So that's a valid answer as well, okay? If you're still trying, I want you to let me know by typing on the group chat, please, that you're still trying. Okay. All right. One person is saying she's got no idea. It's actually a lot simpler than you guys think. Remember what we did here? To figure out like area over here, so you see this is a yellow area here, right? It's also a yellow area. We minus this function from this function, true? So it's same thing for this yellow area as well. So there's nothing difficult. So all you have to do is on here, well, that's a very long answer. I'm not sure whose answer that is. All you have to do is fill in this blank. Just this inside there. From, I'm going to tell you something. This is from 0, from that point here to this point over here, which is 7 pi over 6. All right, so this person is saying, not sure who this is, integral from 0 to pi, okay, sine of x dx. That's 0 to pi. So this person is figuring out this area first. Okay, that's good. And then plus absolute value of integral from negative 0.5 to 0. Okay, that's very clever. Sine. So that's a flipped version of this equation, right? Yeah. So it's a great try. But this is going to be, maybe you meant inverse sine, true? Inverse sine. And then you're doing that area, I mean, this curve minus, so like you viewing this one as up. So you have to do this to dy. So that's pretty clever. Okay, so I'm going to reveal the answer. So the answer is, I think it's just the sine of x minus negative half. So that's another function. So you're calculating area between this function and this function. See, you subtract that from this, then you find all the area here. And remember, area between two curves is never negative as long as you do upper function minus lower function. Okay, so that's the answer. So this one is integration of sine is negative cos of x. And this is integration of positive half. So that's positive half x. And that's from 0 to 7 pi over 6. And that gives us, plug that in, that's equal to negative cos of 7 pi over 6 plus half of 7 pi over 6. And then minus, plug in 0, negative cosine of 0 plus 0. Well, cosine 7 pi over 6 is, I'm just going to use calculator, cosine 7 pi over 6. That's equal to negative square root 3 on 2. So if you want to get this calculator, go ahead. It's really nice because it gives you, normally other calculators give you just decimal places. So that was a negative square root 3 on 2. and this one is 7 pi over 12. Cosine of 0 is 1, so that's plus 1. And this is root 3 on 2 plus 1 plus 7 pi over 12. So that's the answer for this one here. All right. Not too bad. Now, this person's answer here was very interesting. So this person said, it's definitely worth analyzing. Okay, so this area here is done through integral from 0 to pi, because this value here is pi. And if we look at this value, this is a -½ right? And this one is 7 pi over 6. So integration of sine of x dx. So that's definitely going to give you this area here. So that's area 1. To find this area, we're going to integrate it along the y-axis. So obviously, we have y equals to sine of x. So to get this curve and integrate along the y-axis, we have to flip this equation. Then you have to get, x is equal to inverse sine of x. Inverse sine of x. And probably what she meant was, or he meant was, -½ to 0. And then inverse, this is y here, by the way. Inverse sine of y, and then dy. And that's going to give you the blue area, area 2. However, there's something wrong with this one. The reason is the inverse sine function. There's something called, when you have a function and an inverse function. So for example, when you have y equals x squared, that one looks like this, right? But when you find the inverse function, y is equal to square root of x, which is only this bit here. I mean, like, if this is not, we shouldn't really do the inverse function. So hold on. So when you flip, so if I flip the function, so flip the function is y, x is equal to square root of y. But that's only this section here, which is 1/2. So if I have y equals to sine of x, then we have this and this and this. This goes on forever. But if I flip the equation to x is equal to sine inverse of y, then I'm only getting this bit here. Because when you want to flip it, we can only flip the bit that's a 1-to-1 function. So this is a 1-to-1 function here, but this whole thing is not 1-to-1 function. So this is a bit advanced topic, I would say. But this is a really good try. So if I do sine inverse of y, that's only going to be this section and this section here, up to there, right? I'll show you too. So if I go for graph and then do inverse sine, I can only do x here. And let's have a look. So that looks like that, right? Which is actually this bit here, because that's x. It has to look like that. For x is equal sine inverse y, that'll look like this one. So they're symmetrical with respect to the y equals to x. So if you want to know more about inverse functions, it gets quite rigorous and interesting. Let me know. we can maybe organize extra lesson for that this week, end of this week. So for physics as well, if we have to do some extra lesson, I'm thinking about maybe doing it on Saturday instead of Wednesday, because I have some lectures at ANU. Yeah, so let's move on. Okay, so this is multiple choice question. So try number 1, please. So I think it's pretty simple. Just number 1. Yeah, we already answered this one, so yeah, number 1. So what you notice is that this 2, this constant bit is came out of the, if you look at all these choices, they're all outside of this integration. So that means you integrate the 2 and then you have to evaluate from 0 to 2 here. Okay. So take your time. I'm just gonna get some water, okay? So nobody has answered yet, so you can take your time. All right, let's have a look. So C, I think C is the correct answer. C is the correct answer. So let's take a look. Okay, so we need to separate this into two parts. That and that. If you can take the 3 out of this integration, and if you evaluate this is going to be integration of 2 is 2x from 0 to 2. Then you get, this is a plug in 2, plug in 0, you get 4. So this value here is 4. So that's why C is the correct answer. Now try number 2 as well. So A and B are real positive constants, and what is anti-differentiation of this? I'll give you some clue. This is the same thing as, that's 3 there, but the square root is half to the power of half. So this is a 3 on 2. So that's integration of this one. So this is equal to A or B or C or D. Okay, so the answer is, okay, one person is saying A. So you just have to use the anti-chain rule, remember? I'll give you some clue, right? So if you have integral of, let's say, ax, well, let's say 2x plus 5 to the power of 3 dx, the answer is you integrate this one so that becomes power of 4, 2x plus 5 to the power of 4, divided by 4 times by 2 plus c. So that's how you do this one. Okay, so the answer is C, that you guys are right, I think. So if we do this one, raise the power by 1, so you get ax plus minus b to the power of 5 on 2. And divide by 5 on 2, and then you got to times by a, right? So this turns into, and this is plus c here, and this turns into, this 2 goes to the top, so this is a 2 on 5a, and then you can have ax minus b to the power of 5 on 2 plus c. So that's the answer. See here. Now, 37. So also another easy question. The area of the shaded region of the graph is given by. So we want this area here. This one and this one. So try that. Okay. So let's take a look. So definitely it's not B, because if you do from -2 to 2 straight away, then this area will cancel out with maybe this area here. So that's, I'm assuming this is -1 here. So it's going to pretty much cancel with this area. So we don't want that to happen. So let's analyze each one of these. So this is integration from 0 to 2, 0 from here to 2. And this is from 2 to 0. Well, what's that? 2 to 0. But then negative of that. So let's analyze what this is all about. So that's going to give us this area, which is that bit there, right? And then it's negative. And then if I flip this one, then this will be 0 to 2 again with the negative sign at the front again, right? Which is basically the same as this one plus another one of this. So that's just going to be this area twice. So obviously that's wrong. 0 to 2 again, and then -2 to 0. -2 to 0. So this one here is going to be 0, because I think it's if you integrate from -2 to 0, this area and this area will cancel out. And this one over here is going to be that trapezoid, just one of it. D, so that's wrong. D, -1 to 2. This is -1 to 2. That's right. So that's going to be the triangle, big triangle, minus, that's interesting, -2 to -1, -2 to -1. So because that's so yeah, it's down to D and E, right? So should we minus it? So the first bit is triangle. And the question is, should we have negative sign or positive sign? So let's go for this again. All right, so I want you to type your answer, please. Is it D or E? Is that going to be D or E? So if we've only got two answers, it's just very simple. You guys have to just make up your mind, D or E. All right, waiting for two more answers. Okay. So 2 of you are saying E. 3 of you are saying D. The answer is D. The reason is, if you do that, that's -2 to 1, -1, that's negative. So you want that to be positive. We want this to be added rather than subtracted. So you have to put an extra negative sign here to make that positive. If you just do plus, then this is exactly the same as this one here. There's no difference at all. This is integration from -2 to 1, -2 to -1, and -1 to 2. That's the same as the integration from -2 to 2. This will end up getting some cancellation. So you have to put a negative sign there, okay? Now we're going to move on to this one here. So if y equals x ln x, find dy dx. So we already know what that is. We tried that. So that's equal to ln x. Sorry, it was x times by 1 on x plus ln x plus 1, wasn't it? That's a differentiation of that by using the product rule. And it says find the integration of this one. So we know that integration, very simple. Integration of ln x dx was, from the previous case, it was x ln x minus x. So just memorize that, plus c. So a, So this is good to memorize, x ln x minus x, okay? So this is done through integration by recognition. So integral from 1 to e ln x dx, that's equal to x ln x minus x from 1 to e. Plug in e, so e ln e minus e minus 1 ln 1 minus 1. So that's e minus e. So ln e is 1. Minus, this is 0. This is negative 1. So this is equal to 1, because this and this cancels out also. So the answer is 1. If y equals to x ln x to the power of n, what is dy dx? So this is a bit at specialist level. We'll still try. Y equals to x ln x to the power of n. Well, what's dy dx? That's equal to, all right, differentiation of that times by ln x to the power of n. And then plus x times by. We need to do the product rule. So I want you to just notice something here. We didn't do much on logs, but when you have log of x to the power of n, this is not a differentiation rule. This is just log identity. This n can come out to the front. So it becomes an n log x. But you may have log of x to the power of n. So this is not the same thing as n log of x. So this rule only applies if it is just that number to the power of n instead of this whole thing. Now we have this situation. This is the whole thing to the power of n. So this is not the same as n ln x. Okay. Now we have to differentiate. We have to differentiate the ln x to the power of n. But we know that the differentiation of anything bracket to the power of n is n bracket n minus 1, right? So this n comes out and it's n minus 1. So this one is n, and then ln x to the power of n minus 1 times by, because it's a bracket is not x, we have to use the chain rule, and we have to multiply by the differentiation of the inside. That's 1 over x. So if I differentiate this one, that's equal to 1 times by ln x to the power of n, because I'm using the u dash v plus u v dash rule. And then the next bit is u times by the differentiation of that, which is n ln x to the power of n minus 1 over x. But this x and x will cancel out. So that gives us ln x all to the power of n ln x n minus 1. So that's the answer for this one here. So find this one. C says in is given by this. Show that in plus n minus 1 equals to e. So this is a very, very interesting one. Okay. So we found this one here. Now, so integration in is given by 1e ln x n dx. So in minus 1 must be equal to, because in is this, so therefore in minus 1 is equal to 1e ln x n minus 1 dx. Okay. So you can see that y equals to, if y is equal to ln x to the power of n, the differentiation of that is this, right? That's what we found. here. Oh, sorry. This is x ln x to the power of n. So it gets a bit complicated. So integration of this bit here, integration of ln x to the power of n plus n ln x to the power of n minus 1 dx is equal to, well, this bit here is the same as, this is from 1 to e, by the way. That's the same as this bit. But anyway, because differentiation of this is this, integration of this and this is equal to just x ln x to the power of n from 1 to e. And so I'm going to say this is the left-hand side. This is the left-hand side. And this is the right-hand side. So the left-hand side is actually the same. If we separate this into 1e ln x to the power of n plus, this is a n. This n can come out. And then this is a ln x to the power of n minus 1 dx. So this one is the same as in. See that? Plus, this is an n, and that bit there is in minus 1. So that's my left-hand side. My right-hand side is this one here, which is x ln x to the power of n, 1e, and then you plug in e and 1. So let's plug in e, okay? So that's e ln e to the power of n minus, plug in 1, 1, so that's a 1 ln 1 to the power of n. But the thing is, ln e is 1, so this thing is just e, and this thing is just a 0. So therefore, we prove that that is equal to this one. Okay, so in plus n minus 1 is e. So leave this one as homework, hence find this. That's pretty simple. Let's actually just do this now. So we established this rule. This rule here. So I3 plus 3I2 is E. That's what we can use for this one over here. Okay. And we also know that I2 plus 3I1 is E as well. So by recursive relationship, we can figure out what I3 is. This is I3. Okay, so that's a challenge problem for you guys. Okay, so this is still from this methods book. Okay, so this is a yellow methods book. So this is a year 12 methods book. So this is not, it's somewhere in between specialist and methods level, right? So you guys can definitely try this as homework. I'll paste the solution for this one later on EDX. I'll take a picture of this. Just give me a second. All right. Now, let's move on to, so it's 7:15 now. Let's now talk about normal approximation to binomial. So this is also very, very important topic. Okay. Just a little bit of revision on binomial first. So binomial distribution was used. So X is the number of successes, and N was the number of trials, and P is the probability of success. Now, if there are 30 days in November, of course there is, in November, chance of rain is 0.3 every day in Canberra. So there's a 30% of chance of raining in November in Canberra. So for example, you may have no rain, rain, no rain, 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 no rain, etc., ending with a rain, rain, no rain. So this is a particular arrangement of 30 days. Now you may want to know what is the probability, or what is the most probable outcome? What is the expected number of days of raining? So can you guys answer that question, please? What is the expected number of days of rain, or the expected number of successes in this case? So we have 30 days, and probability of raining is 0.3. Okay, so the answer is 9. Well done. The formula for that is NP. So that's equal to 30 days times by 0.3, and you get 9 for that. So the most expected outcome is 9 days. But also probability, and the variance for this was equal to NPQ, right? NPQ. So variance for this is equal to 0.3, that's 30 times by 0.3 times by 0.7. So we get about, Q is simply 1 minus P, all right? So this one is, how much was it? Sorry. That's 6.3. This is NP 1 minus P. That's 6.3. Now you might want to ask this question, how do I get probability? What's the probability that it exactly, so there are 30 days available. Of course you can get 1 day of raining, 2 day raining, 3 day raining, 4 day raining, etc., all the way up to 30-day raining. Of course, 30-day rainings, that's very, very improbable. And also just 1 day raining or 0-day raining, that's also very, very improbable. So we expect distribution of the probability to go like this. So it's quite low. 0, 1, 2, 3, 4. So towards 9, it's quite big. And then for the rest, it's quite small. So this is about 30 days around here. This is X. So we get some distribution like that, okay? So to find the probability that 9 days rain, exactly 9 days rain, then you have to do 30C9, and then 0.3 to the power of 9, and then 0.7 to the power of 21. So we learned that one, right? So if you want to get that, simply we can use a calculator. So every calculator has this function called binorm. So you see, I clicked on binorm there, and it's asking me PD, CD, right? BPD, BCD. So PD is, so every calculator has this. PD, if I click on PD, then I just need to click, type. I want 9 successes. I want 30 trials. I want probability of 0.3. And the answer is there is about 15.73%. So this is 0.1573. I can calculate 8. I can calculate 10. So that is 30C8, 0.3. So if you don't have this calculator function, then you have to type all of this manually. Okay, and this is 30C 10 and then 0.3 to the power of 10 and then 0.7 to the power of 20, 20 here. So if I calculate all of that, so that all I have to do is just change this to 10. That's equal 0.14, 0.1415, 16, sorry. And then all I have to do is just change that to 8. And that's equal to 0.15. So if I just add all this up, that takes about, so these three values alone is about 45%, right? So that's taking a lot of the probability. So about 50% of the time, so if you take any random November, around 50% of the time, it will either rain 8 days or 9 days or 10 days. That's what it's saying. So if I want to calculate all of this all at once, all I need to do is do this. Binom CDF and calculate, so the order in which they occur. So different calculators have different order, but usually it's with X, N, and then P, okay? So I'm gonna do 10, 30, 0.3. So what that means is, this one is probability that X is less than equal to 10. So what that means is I'm calculating probability of 0, probability of 1 day raining, probability of 2 day raining, etc., all the way up to probability of 10 days raining. So there is a button for that, which is the CDF, distribution binom CD. So if I go for 10 here, and everything else is the same thing, then what it means is this. This is a 73%, right? 0.73. That means there is 73% chance that it'll either rain 0 days. So it's a summation of all of this. Okay, so probability that it rains 11 days or above is going to take about 27%. Right? Now, but I just want to calculate these values here, these three. So what we did here is calculate from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I calculated all of that. All I need to do is subtract 1, 2, 3, 4, 5, 6, 7. Then I can get these three. Is that right? So I can do probability that X is less than equal to 7. That's binom 7, 30, 0.3. So if I do that in my calculator, so that's 7 here. Then up to 7, it's only 28%. So if I take that away from 0.73, so 0.28, 14. So if I take that away from 0.73 minus 0.2814, then I get 0.4486, right? That's that one here. Okay? So that's how you do using the binom CDF, okay? There is CDF and PDF in all of this. So you can see that as for normal distribution, you don't have to worry about PD. You only have to worry about the CD and inverse. For binom, because it's discrete probability, PD is quite useful if you're trying to figure out probability of one specific event. But because normal distribution is continuous, this NPD is still there, but it's about, don't worry about this for now. If you want to know, just let me know, okay? Yeah, you only have to do normal, the NCD, okay? Now, the problem is, so what is normal approximation to binomial? So what is this all about? So this is how you do it. you treat this distribution as if it's a normal distribution with the average of mu, which is the NP right here, right? And the standard deviation, so the mu average is 9, and the standard deviation is square root of 6.3. And then you form a normal distribution, perfect normal distribution with 9 in the middle. And if you want to find the probability that x is between inclusive as well, 8 and 10. So we wanted to calculate this one and this one and this one, right? We simply extend this one because there's a 9 here and this is a 8 here and this is a 10 here. And we calculate this area. So we're treating this as if it's a normal continuous distribution. Of course, in the discrete distribution, each of these bars represent probability, but in continuous distribution, area is the probability, isn't it? So we do that, and let's see how this one compares with this calculated value, which was about 44%, right? So if I take this calculator and go to normal distribution, normal, CD, and I go for 8 and 10. So this is in between 8 and 10. Standard deviation is square root of 6.3. So that's about 2.5. And the mean is 9. And if I do that, that gives me about 30%, 31%. So how does that compare with our 45%? Are they pretty close or not? You can type your answer or you can use your microphone. So here, I got 31%. So this area is 31%. But this is 45%. So are they pretty close or not? So not close, right? So here's what you have to do. You have to take, so this is 7 here, and this is 11 here. But you see that if I want to calculate probability between 11 to about, let's say 13, then you would do 11 to 13, right? Then you would calculate this area. But the problem is, what is this middle area then? Where does that belong? Does it belong to 10 or does it belong to 11? So the thing is, half of this belongs to 10, half of this belongs to 11. So you're supposed to, if you want to calculate the probability between 8 and 10, so in this case, you could just do 8 and 9 and 10. Just add them all up. But if you are doing normal approximation, you have to calculate area from, guess what? From 7.5. So half of this belongs to 8 and 10.5. So let's change those values and see how they compare. So go over here, and this is 7.5. So it's getting a little bit larger area, right? And if I do that, that's equal to, well, that's 44. That's very close, isn't it? That's very close. So this is what people used to do. This is known as normal approximation to binomial. So why did people invent this way of calculating binomial distribution? The reason is this was just too much, and people didn't have this function in their calculator. They didn't have a calculator. So what they did was, oh, let's assume that this is a normal distribution. And using z-score and everything, because you guys have seen the z-score table, right? And people have access to that. So using that, they approximated this this area, this probability. Okay, so I'm gonna give you the normal distribution chart. let's imagine we are generation without any calculator, okay? So we're going to be using this table. Okay. Here's the table. And here's the problem. There are 100 light bulbs. It is known that 3%, the probability that you, when you pick a light bulb, probability that you find the defective light bulb is, let's say, 0.04. Okay. So you have 100 light bulbs. So obviously the expected number of the defective light bulbs is 4, 100 times by 0.04. I would like to know the probability that between 4 and 15 are defective. So what is the probability that when I have 100 light bulbs, either 4 are defective or 5 of them are defective, etc., all the way to 15 are defective? Okay, so what's the chance of that happening? Because let's say if, or maybe I want to do just this. So let's say some inspector comes. Let's say some inspector comes and inspects 100 light bulbs, and if he finds more than or equal to 4 bulbs defective, then this factory has to shut down or something. Okay. So as the factory owner, I would like to know what the probability is for this inspector finding 4 or more light bulbs defective. So this is probability that x is equal to 4, probability x is equal to 5, all the way down to probability x is equal to 100. Okay? And all you've got is this table over here. Okay? So you can create a normal distribution with 4 in the middle. And the standard deviation is square root of NPQ. And we need to go for, so this is a 4 or more, right? So we need to go for 3.5. We need to find this area here. Okay? This area, 3.5, sure? Because we're looking for this one here. Therefore, I need to do this. So mu is 4. Standard deviation is 100 times by 0.04 times by 0.96. So let's try that. So 100 times by 0.04 times by 0.96. And then if I take the square root of this, that's a 1.96. 1.96. Okay, so now let's figure out the z-score of this one here. So obviously, if you can translate this to z-score, you get 0. And this value here is The z-score is x minus mu over sigma. Remember this? So that's 3.5 minus 4 over 1.96. So that gives me 3.5 minus 4 divided by 1.96. Then you get negative 0.255. Negative 0.255. So we need to find 0.255. 0.255 is halfway between those two, right? So that's halfway between those two. So I'm going to take the average between 0.5987 plus 0.6026. So that gives me that. And that's going to be, because this z-score table only gives me area for positive z-score. So this one is 0.255 and the area is 0.6. 60065. Okay, so I think that area here, wouldn't that be the same thing? Like this area here, I think that would be the same as this area here. Is that right? Because this area here, this area is the same as this area. That's 0.255. That's also 0.255. It's symmetrical. So this area here must be 0.60065. So that means there is a 60% chance. So that's very dangerous, right? This inspector finds more than 4 bulbs defective. Let's do this using the calculator. Without the normal approximation, I'm going to do the binomial. Okay, binomial CD variable. So I'm going to go for 3, so up to 3. So that's including, because it's CD, I'm including 0, 1, and 2, and 3. Number of trials is 100. Probability 0.04. If I do that, that's equal to that. So if I subtract that from 1, so 1 minus 0. Why do I do that? Because. So you see that's equal to 0.57. So if I'm doing the binomial, that's 0 defective, 1 defective, 2 defective, 3 defective, 4 defective, and then 5, 6, 7, like this. So if I count, so this is I want to calculate all of this, right? More than 4 defective. So I need to subtract that from 1. So the true answer is 57%. That's the true answer. If I use the normal distribution, hold on, it's frozen. Okay, there you go. So if I use normal distribution, and then I go from, so instead of the z-score, I can just go straight away into 3.5. So 3.5, because that includes the 4. So above 3.5 is included in 4. And then I just go for 99999. It's a very high number. Or maybe I can go for just 100, because 100 is the maximum, maybe 100.5, but that's high enough. Because it's normal distribution, it doesn't have to end with 100, so you can just go for just a 999 maybe. And the standard deviation is 1.96, it was. And the mu was 4. If I do that, I get 0.6. That's exact 0.6006. That's exactly this one, which we calculated from this table here. Okay. So for this subject here, so discrete random variable and continuous random variable and normal distribution and binomial, my recommendation is not use calculator. Okay, because people in the past they used only this to work at everything, and people learned a lot more. But nowadays, teachers are just asking you to just tap on the calculator, but you're not learning anything if you just do that, okay? So, yeah, my recommendation is just try to avoid using calculator as much as possible, okay? All right, now let's move on. So that was binomial, normal approximation to binomial. So if you guys understand this. Now, let's move on to these questions. So this is about expectation algebra. So just a revision. So if we have this such probability distribution, then we can draw a table like this, and x value could be 2, 2, 4, 4, 16, 64. And probability is, it does not depend on this value. So this is 0 0.25, 0 0.25, 0 0.25, 0 0.25. So I want you to figure out the expectation value of x, please. So try that. I'll leave that as your question. So I want you to try this one, and this one, and this one all together, okay? And then put them here with, separate your answers with comma. And we're going to talk about this one later. So I haven't got any answer yet, but remember, if you want to calculate the expectation value, you have to multiply this by this, and this by this, and this by this, and this by that, and add them all up. Variance was expectation value of x squared minus expectation value of x all squared. So to do that, you have to create another row. And this is x squared, and this is a 4, 16, and this is 16 square and 64 square, right? And you have to do this one by this one by this one by this, and this one by this. And that's going to be that value, and that's the expectation value of x squared. Yeah, so that can come from this one here, right? And once you calculate that, you can just take square root of this one here, and then you get the standard deviation. Okay, so I've got some answers here. All right. Another answer. So these two people agree, 21.5 and 630. Standard deviation is a 25.11, so they all agree, right? Yeah, so I believe this is the answer. So let's double check. So if I do 2 by 0.25 plus 4 by 0.25 plus 16 by 0.25 plus 64 times 0.25, so that gives us 21.5, right? And if I do 4 by 0.25 plus 16 by 0.25 plus 16 square times by 0.25 plus 64 square times 0.25, that's equal to the expectation value of x squared. So minus 21.5 squared, that's the expectation value of x squared. That gives us 630. If I take square root of that, then I get 25.11. So that these two people are correct. Okay, so how do we calculate this one here? Well, that's a bit interesting. So we know these rules, right? Expectation value of ax plus b is equal to expectation value of it was a expectation value of x plus b, right? So if I have expectation value of 1 over x, is that going to be 1 over expectation value of x so that it's 1 over 21.5, which gives us, like this person says here, 1 over 0. 21.5. So we never encountered such situation before. So this one's a 0.05 if you round it up. 0.05. This is not really the same as this rule here. This only works when it's a linear multiplication to this one. So I think we have to, I don't think we can use this rule. So I think we have to construct a separate row and go for 1 on 2. So this is 0.5. So this is a 1 over x. I should do this in more bright color. So this is a 1 on 4. This is a 1 on 2. This is 1 on 16. This is a 1 on 64. So the expectation value of 1 over x is half times by 0.25 plus 1/4 times by 0.25 plus 1 on 16 times by 0.25 plus 1 on 64 times by 0.25. So this is the correct answer. But let's check if this is the same thing as this one here. If that is the case, then this rule here will work. Okay, is working. Now, so 0.5 times by 0.25 plus 0.25 times by 0.25 plus 1 over 16 times by 0.25 plus 1 over 64 times by 0.25. That gives us 0.21. Yeah, so you have to do this manually, like this. You cannot, so this is a shortcut, but this was pretty clever though. If you thought about this one here, that means you remembered this rule here. But unfortunately, this is an exception. It only works if it's a linear equation like that, okay? Ax plus b. Okay, so I hope that makes sense. Now let's move on to this question here. So this is simple probability revision, guys. All right. Just a little bit of brief revision on probability, guys, okay? So there is independent probability, and dependent probability. So this is for people who need some revision on probability. Well, let's try this one first, and then we're going to do some revision on probability, okay? So random variable x is such that this one and this one, the standard deviation is equal to. Well, that's very simple, right? So this is a 1.69 minus 1.2 square. That's the variance. Variance is that one minus that one square. So what is the standard deviation? That's just square root of these two, right? So that's equal to square root of 1.69 minus 1.44. I believe that is right. 1.2 square is 1.44. So this one is square root of how much? 0.25, which is 0.5. So I think that is the answer here. So we didn't really go through probability rigorously, but that's a prerequisite knowledge, right? So just gonna do some brief revision on probability. So very simple. So you have to know about Venn diagram. You have to know about tree diagram. And you have to know about event space. So let me show you about event space. So let's say there is a tetrahedral die and there's a cubical die. So some people already went through this before with me. So the number of outcomes for this one is 1, 2, 3, 4, and outcomes for this one is 1, 2, 3, 4, 5, 6. So if I draw the event space, and this is a 1, 2, 3, 4, 5, 6, and this is a 1, 2, 3, 4. So event space is given by 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. So these are all the possible list of all the possible outcomes. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Okay. So I'm going to just omit the commas. I'm going to say event A is 4 on the tetrahedral die, and event B is 6 on the cubical die. Now, what is the, so this is a A or not A, and this is a B and not B. This is a B and not B. So usually, when you look at a tree diagram, so each branch adds up to 1. So obviously the probability for, so let's have a look at all of this. So the event A is given by this. That's event A. Event B is given by all of this. That's a 6 on the tetrahedral die, right? I mean, the cubical die, sorry. So that's event B, this is event A. So obviously they overlap, right? So the event A or B is the number of that is, I think it's how much? 15, is it right? No, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's actually 9. Number of events for A is 6, and number of events for B is 4. So that's why we get this famous equation. A or B A or B is A plus B minus A and B. So we can apply that to probability. So this is 9 equals to 6 plus 4 minus A and B. Obviously, that's 1. That's this guy here. That's A and B, okay? So if we draw a Venn diagram for this, so obviously the probability for A happening, so there are two ways of looking at it. So probability of A happening is, if you look at this one here, it's just definitely 1 out of 4, right? If you look at this, and also probability of B happening is 1 out of 6. So that's equal to 1 out of, yeah. If you look at this, this is, there are 6 outcomes. So obviously getting a 6 on the 6-sided die is 1 out of 6. But if you look at this whole thing, the total event is 24, and out of that, the blue takes up 6 of them. So 6 out of 24 is also 1 out of 24. And 1, 2, 3, 4, that's 4 out of 24. That's also 1 out of 6. And you can see that the A, the probability for that is 1/4. Probability B is 1 on 6. And this is a 5 on 6. And this is a 3 on 4. This one is 1 on 6. And this is a 5 on 6. See? Now, if we so for tree diagram, we have to multiply across. So if you multiply across, then we get 1 on 24. This one is 5 on 24. This one is 3 on 24, and this one is 15 on 24. So this is event A, this is event B, and we see that event A only, so this section here is event A only, and that is A but not B. So that's 5. So there are 5 of those, and that is represented by these 5. 1, 2, 3, 4, 5. So these are event A, but not B. So it doesn't include that, right? The intersection there is 1. There's only one event. One case is 4 and 6, right? So that's 1. And 1, 2, 3, that's B only. 3 here. So you can see. Hold on. What's the sound? I think there's some car alarm going off. So this bit here is this middle area, and this bit here is this area here. So that's A, but not B. This area is not A, but B, like this. And this area is 15 out of 24. That's the rest. So that's the outside of those circles. So that's so all of this. That's 15 of them. So that's the relationship between tree diagram, Venn diagram, and event space. So I hope that's all clear. But now what's really interesting is that sometimes you get, so here's what independent probability is. Independent probability. So so let me ask you this. Is event A independent from event B? What that means is, does what you get on the tetrahedral die, does that influence what you get on the cubical die? The answer is no. They are two separate events and they don't influence each other. So they're independent. So that's what it means. So whenever you have independent probability, what happens is when you look at the tree diagram, I mean Venn diagram, this one here multiplied by the other circle is going to equal to this middle here. So have a look at this. Probability of A was 1 out of 4. Probability of B is 1 out of 6. And when you multiply A by B, we get 1 out of 24. And that is the probability of A and B. So that is the middle area here, isn't it? So this is a 6 out of 24, which is a 1 on 4, right? This one is 4 out of 24, which is a 1 on 6. You multiply that, you get 1 on 24. Is that right? See, when you multiply that by that, you get this one, and that happens to be the middle area, right? But if you multiply A by B, but you don't get the middle area, middle probability, then that's not independent probability. That means they depend on each other. Okay, so this is the relationship that proves that this is an independent probability. Okay, so that times by that gives us that, which is the middle probability. Let me talk about dependent probability. So this gets very interesting. So I assume that no one has done any probability in year 11. Is that right? Sarah, did you do any probability in year 11? Honey, Nimesha? Alan? But in year 10, right? So this is a long time ago. So I think it's good to revise, isn't it? Because in year 12, in semester 2, you will definitely be, this will be prerequisite knowledge. It'll be an assumed knowledge. And things will move really, really fast. So I think it's a good idea to revise this now. So now let's talk about dependent probability. So let's say that probability that it rains is 0.3, and probability that it doesn't rain is 0.7, of course, on any particular day in Canberra. So from now until like forever, any day there's going to be a 30% chance of raining. I'm not sure if you like that or not, but I think Canberra needs some more rain. So, and let's say if it rains, then probability that you go to school late is 0.5, and probability that you're not late is 0.5, of course. And if it's not raining, then probability of you being late is 0.1. So that's significantly low. And if it's not raining, probability of not late is, of course, not. So 90% of the time you're going to arrive on time. So you can see that depending on what your first branch is, the probability of your second branch changes, right? It was 0.5 here before, now it's 0.1. So that's why we put this symbol, L, late, given it is R. Not late, given it is raining. Late, given it is not raining. Not late, given it is not raining. Okay, and still this rule applies. This, if you multiply this by this, it's going to give you this. If you multiply this by this, it's going to give you this. If you multiply this by this, you're going to get that. And if you multiply this by this, you're going to get the outside area. So we're going to fill all these things in. So that's equal to 0.15, right? 0.15. And this one and this one is 0.15 also. This one and this one. So I'm not counting like how many numbers go there. I'm writing down the probability. So if you simply divide all these numbers by 24, 24, 24, and 24, which is the total number of events, then you get probability. So here, I've got 0.07, and the outside is 0.663. So if you guys follow everything so far. So this one is probability that it is going to be rain and, so this is also rain and light. This is a rain and not light. Rain and not light. This is a rain, not rain, but you're late. This is the probability of not raining and not light. So let me ask you this. What is the probability that it rains? Anyone? So I'm not going to run the soccer tape. You guys can just type on the group chat. And what is the probability that she is late? Well, we can run the Socrative if you want. So off you go, you can try. Okay, I've got one answer from Honey. You guys can also try. So obviously this is 0.3. It doesn't change. I said the probability of rain is 0.3, you know? So that's 0.3, you know? And you can see that this is rain here. That's 0.3, right? So what's the probability of light? So this part is light. Obviously, if it is raining, if it is given that it's raining, then your probability of light is 0.5. If it is given that it is not raining, then probability of light is 0.1. So it's 0.5 if it is, so probability of light is 0.5 if it is raining. Probability of being light is 0.1 if it is not raining. So how do we figure out the probability of just being light? Well, you have to figure out this number here and this number here. That was 0.15 and 0.07. So that was probability of rain and light, not rain and light. So those two cases are the light cases. And as you can see from this Venn diagram, that's equal to 0.22. So Honey, you got it right. So that's not right here. 0.05. So this was right, but this is not right. Okay. So now let's have a look. Probability of raining times by probability of light. Let's multiply these two and see what we get. Okay. So that's equal to 0.3 times by 0.22. So that gives us 0.066. Is that the same as this middle probability? It's definitely not. So this is an evidence. Of course, looking at this tree diagram, you can definitely see that these two events are not independent. You can see that whether you're light or not light depends on whether it is raining or not. So it is a dependent probability. So we can obviously see that fact through this tree diagram, but we can also verify that using this rule here. That times by that is equal to this, which is not the same as the middle. This is the litmus test to figure out whether it is dependent or independent. Okay. Now things get a lot more interesting from here. Now, so what we can do is from here we construct this equation. Probability of A and B is probability of A times by probability of B if it is independent. Probability of A and B is given by probability of A times by probability of B given A. So you see, this is R times by L given R is P, R, and L, right? Here as well, R times by L dash R, that's R and L dash. Probability of R dash times by L given R dash is R dash and L. So that's the dependent case. So do you guys follow everything? So if it's independent, this one times by this one will equal to this one. But if it is dependent, then this one times by this one. So this is still B, but it's given A. That will equal to this one. Not P of A times by P of B. This will not equal to this one because it's dependent. But we can also let A and B equal to P of B times by P of A given B. This is time is 8:11 now, guys. So if you have to leave, you guys can leave. You're more than welcome to leave. if you have dinner or something. You guys can watch the recording later. No obligation to stay. But I'm gonna finish this one, and we'll finish around 8:20, all right? So this is the formula for conditional probability. So it gets very, very interesting. Let's say Sarah is the person who obeys this rule here, okay? Who is under this rule. So when it rains, then her probability of arriving changes, okay? And let's say Honey, her friend, is in classroom and watches outside and it is raining. So it is raining outside. So Honey can say, oh, and Sarah hasn't arrived yet. And she wants to make some prediction about the probability that Sarah is going to be late given that it is raining. So that is equal to, so it is given that it's raining outside. So she's observing that it's raining outside. And she has this table, and she can tell that the probability that that she's going to be late is 50%. So 50% she's going to be late, 50% not late. And if it's fine on the outside, sunny, then she can make prediction about Sarah being late and not late. Chance for Sarah being late is 0.1, just 10%. And not late is, so you guys can understand this, right? So that's easy to understand because you have this table. But now we have, let's say there's window here, but let's say this window is all sealed and Honey doesn't have any access to view outside. So she has no idea, absolutely no idea what the weather is. And one day, Sarah arrived on time. Sarah arrived on time. So it's, but maybe let's say she arrived late. And based on this fact, she wants to know the probability that it's raining outside. So that's completely reversed. So then she needs this table. Late, not late, and then raining, not raining, raining, and not raining. This is a given L, given L, given L dash, given L dash. So what is that going to be? That's a bit more complicated, you know? So what she needs to do is use this formula right here. Use this formula, and she can also use this table here also. So what she wants to do is this. Okay, so given that it is raining, given that Sarah arrived late, what is the probability that it is raining? So the formula for that is P of R and L, very simple, over P of L. So where does that come from? It comes from this equation here. So you can see that P of a B given A is this one over this one, right? So this is a P of A and B over P of A. What about this one here? That's a P of A given B. That's equal to P of A and B divided by PB. So whenever you have A given B, that's A and B over B. When you have a B given A, that's a P, A, and B still, and you have A here. So what's over here goes to the denominator. So if she's using this formula, she can figure it out. What was the probability according to this table? R and L, that's equal to 0.15. That's this one here, right? 0.15 over probability of late was all of this. That's 0.22. And that is given by 15 on 22. So 15 on 22, that's equal to about 0.68. So that's 15 on 0.68. So there's about 70% chance that it is raining outside. So we can construct this new table. So you can see that the probability of light was 0.22. Not light, of course, is 0.778, right? And this one here is, we just found it. This is 0.68, right? 0.68. And this one here obviously must be 1 minus that. So that's equal to 0.32. And we can figure this one out as well. So probability that rain given not light is obviously probability of rain and not light over probability of not light. So that's equal to 0.78 from here. And R and not light, we can figure that out from the original table. That's equal to this one here, 0.15 as well. R and not light, that's 0.15. So that's a 15 out of 78. So that's a 15 out of 78. So this would be a 63 out of 78. Okay. So this was 15 out of 22. So this should be 7 out of 22. So we got this new tree diagram. So therefore we can, but we're going to get the same. We're going to get the same Venn diagram here. Same Venn diagram. Okay. Yeah. So, so if the windows are all sealed and Honey doesn't have any access to the outside world, then she has this new table now. So let's say one day Sarah arrived not late. What's the probability that it is not raining? So not late. What's the probability that it's not raining? That's just 63 out of 78. Okay. But let's say she doesn't have any, she's absent from school. So she has absolutely no idea whether Sarah is on time or late, whether it's rainy or sunny outside. So she's just at home, maybe lying on her bed, all right? And she wants to make some, out of blue, she wants to make prediction about Sarah being late as well as raining. That's just going to be that times by that. That's not just single those values. It'll have to be combination of two branches, that or that, that or that. So that's the difference between the given probability and the product of those two. So you need to really make sure you know the difference between P, A given B and the probability of A and B. So that's just a single branch from, select one of those, okay? A and B, for something like that, if you want to go for and, that's multiplication of two branches. This or this, or like this or this, or this or this. Now let's have a look at this question that we couldn't do. So this will make a lot more sense. Okay, so that's probability of A. This is probability of B. Well, let's multiply. So this is A and B, right? So you can see that probability of A is 1/2, but probability of A given B is 1 on 6. So now, if A given B was the same as just 1 on 2, which is like probability of A is probability of A given B, this means A does not depend on B if they are the same, right? So the fact that A given B is different from A, that is evidence that this is dependent probability. This is conditional probability. So these two events are not independent. They depend on each other. So obviously P, A, and B is A times by P, B given A, or it is P of B times by P, A given B. So you can use anything you like. So we can maybe use this one. That's 1/4 times by 1 on 6. So that's equal to 1 on 24. Okay. And what is a P, A, or B? Well, we can figure out, so we can now construct some Venn diagram. So Venn diagram will be the easiest. So we figured out A and B, right? So that's 1 on 24. But A is 1 on 2. So if I take away 1 on 24 from 1 on 2, that's 1 on 2 minus 1 on 24. That's equal to 11 on 24, of course. This is 11 on 24, right? And if I do B minus this one, then I'm gonna get this B only section here. So that's a 1/4. So that's 1 on 4 minus 1 on 24. That's equal to 5 on 24. Then obviously I can fill out the rest as well. That's 12, 17, so it must be 7 on 24 here. 7 on 24. Now we can figure out A or B. That's summation of all of this. That's A or B. That's together. So that's equal to 17 on 24, right? So this is a 17 on 24. This was 1 on 24. Now let's try A, not A given B. But we can try that using that formula. Actually, with this one here, so you can do both tree diagram, like this, like this. This is A, not A. This is a B given A, not B given A. This is a B given A not, and not B given not A. So we cannot find that from, we cannot find this one from that tree diagram. So you can also construct, so this is a homework for you. You can do B, not B. And then B, A given B, A given B, not A given B. And this one is A given not B, and the A not given not B. So you can fill all that in using this table here. But I'm going to use a formula to figure this one out. That's probability of not A and B over probability of B. That's the formula. So not A and B is, here. That's this section. This is B only. This is B as well, but this section is B and not A, right? That's 5 on 24. Over probability of B. That's equal to 6 on 24. So that's 5 on 6. Okay, so that's 5 on 6. We can try this one. That's equal to probability of A and B naught over probability of B naught. So A and B naught is 11 on 24 over probability B naught. B naught is outside of all of this. So that's this one. That's 18 on 24. So that's 11 on 18. So this is 11 on 18. Okay. There was one more thing that I wanted to talk about. Just a very small thing about probability. I forgot what it was. So yeah, you have to do this as homework. Try that as homework. I'll definitely screenshot all of this to you. But hold on. That was one small thing. Just give me a second. So how do you guys feel about this probability section here so far? Raveen and Honey and Sarah? Is this something that you guys knew before, or? Okay, what about Raveen? Yeah, okay. So definitely I think in year 10, they just go through this without like this. So what we did is a full analysis of all these probability. Like in year 10, people just learn it mechanically and just use formula. But I think this is giving you like the bird's eye view of everything, right? On probability. I think we should just call it a day. Yeah, and if I remember what I was going to talk about, then I'll let you guys know. Okay, it was just a small thing about some common misconception that people make. I just forgot what it was. So yeah, we'll call it a day and see you next time. See you tomorrow for chemistry.